To test h sub 0 where mu is equal to 20 versus h sub 1 where mu is less than 20, a simple random sample of size n equals 19 is obtained from a population that is known to be normally distributed. If x bar is equal to 18.5 and s is equal to 4.2, compute the test statistic. So we're going to do stat, go over to test, and then t-test. And input is statistics, and mu naught is 20, and x bar is 18.5. Sx is s, which is 4.2, n is 19, and mu is less than mu naught, and then calculate. So our test statistic here is negative 1.5556749623, and I'm going to go and write the p-value. So our p-value is 0.068468717. So B asks us to draw a t-distribution with the area that represents the p-value shaded, and then draw a t-distribution that depicts the critical region beside of it if the researcher decides to test the hypothesis at the alpha equals 0.05 level of significance. So we have two distributions here. So our bell-shaped curves and our region. Here. So the p-value is actually the probability that t is less than negative 1.56, and that is equal to 0.0685. So this region is 0.0685, and this value textbook uses as t naught is equal to negative 1.56. Whereas over here, this region is alpha, which is 0.05, and this is going to be negative t sub alpha since we have a left-tailed test. And we're going to use our table again to figure this out. So our area to the right, if we use symmetry here, would be 0.05. And then degrees of freedom, we do n minus 1, so we're looking at 18. So using our table, 18 degrees of freedom, 0.05 is 1.734. So this is going to be negative 1.734. So you can kind of see those two side by side and see what's actually going on now. So again, remember that the p-value is the probability of obtaining a sample mean, in this case, extreme or more extreme than the one that you calculated from the sample. Okay. So C asks us to approximate the p-value. So our p-value is let's write that down here. So we just want to pick the range that it's in between. So it's in between this last range here. And then lastly, we want to know, will the researcher reject the null hypothesis? So our p-value versus alpha. So our p-value here versus alpha. So our p-value is greater than alpha. So again, if you're not sure, do your p-value minus alpha. If you get a positive value, the p-value is greater than alpha. So, so the p-value is greater than alpha. We do not reject the null hypothesis, and it doesn't fall in the critical region here. So the researcher will not reject the null hypothesis. Oops. There is insufficient evidence to conclude that mu is less than 20.